So introducing Parked. So here's some background on our app. So it began from our team realizing just how inefficient the current parking permit system at Santa Clara is. It requires printing and manual distribution of each parking permit during each quarter or each school year, which makes it easy to misplace, forge, or even forget to display parking permits. This also results in wasted plastic, paper, and ink, which all could be done by software. Likewise, this all requires manual enforcement, which is highly inefficient and time-consuming, results in higher administrative overhead costs, and ultimately results in enforcement delays. So currently, SCU lacks a system where they can simply verify, technologically speaking, whether someone has a parking permit or not. Likewise, I spoke with a member of the transportation services at SCU, and they say that they agree that this is a problem and are open to student solutions, is where we come in. So our solution is Parked. Instead of visually searching whether a car has a verified permit, now campus safety officers can just use their phone to scan it, and it ultimately tells you if a given car has a permit based on their license plate number. It extracts your plate number and checks it against a digital permit list. This is a student-built tool that utilizes an ML platform for plate recognition and ultimately simplifies parking enforcement and improves the parking experience for everyone.
The leftmost screenshot shows the homepage of our app that has our logo and a button to start the process. The following screenshot shows how we can now have a live camera feed that lets you scan and take a picture of a car and focus on its license plate. Then we can either have a valid permit or an invalid permit. It gives you a green box if it's valid alongside its actual text, or a red box if it's invalid alongside its actual text.
So technically, how does it work? Well, in our React Native front end, you upload an image, and that image is sent to our API endpoint, which is hosted in Vercel. And with that image, we use our trained model to detect bounding boxes on the license plate, and then we crop the image to those bounding boxes. We then take that image, we grayscale it, denoise it, etc., to pre-process it using OpenCV. We then take that processed image, and we perform Paddle OCR on it, and that basically extracts all of our text. And we take that text and we choose the one by filtering it through its size and a few other features to return only the plate number and nothing else. We then take that plate number and we match it against DynamoDB database and see if it's valid or invalid. You can see here's an example of an already cropped image where we've pre-processed it and then we found all the text, but we only want the plate number. So we take the box with the largest area, which is the plate number right here, and we keep it, and you can see that it detected the plate accurately.
And then we use a DynamoDB database that stores all the license plates so we can fact check whether they're valid permits or invalid permits.
Here are some results that we had from our training, our machine learning model in Intel Tiber. We used the Intel Tiber CPU and GPUs to train our image detection model that detects where the license plate is on the car. And as you can see from the results, our errors went towards 0, and our precision and accuracy went towards 1, which means accurate. All right.
And why now? Well, Park is built by students for the university. There's no need to outsource expensive third-party systems because development is in-house, meaning faster iteration as well as lower cost. And currently, parking operations are costly and manual. Permits can cost money to print, distribute, and replace. Enforcement is time-intensive and error-prone. And small little inefficiencies like that compound over thousands of vehicles and tickets per year. Additionally, with Park, the system is more modernized and it's greener. The plastic, hang tags, and paper tickets generate waste. Parked helps SCU reduce its environmental footprint, which aligns the university's sustainability and smart campus initiatives. And it's the right timing. The infrastructure is here. Intel Tiber makes fast ML possible on student devices. The transportation department is already on board to pilot this project. And SCU has a chance to lead among peer universities with a homegrown solution.
And here's our demo.
Hi, my name is
Hi, my name is Enrique. We're building Parked. It's a tool that checks if a car's license plate is registered with a valid parking permit. So in front of me, I have this car, which is registered in our database, and this one that is not. And so Ivan here is going to demonstrate. Here, he scans the plate, it's processing. Boom, valid permit. All right. And now this car should not be valid. Here we go. Takes a picture of the plate, processing, and boom, invalid. All right. So here's our product roadmap. So we begin with just the simple MVP, the minimum viable product, which is just an image-based license plate scanning app with OCR. This includes local permit checks, currently built on Intel Tiber and presented and tested in React Native. Phase 2 was the campus pilot, was when we hope to pitch this to the transportation services at SCU. In this case, we'd release the App Store and connect it to SCU's actual parking database. Likewise, we'd partner with campus safety to test in real parking lot and collect feedback and usability. And once we begin a full rollout, then we'll have real-time scanning with the mobile app. We'll have an admin dashboard, authentication, permit sync with students and faculty, logging, analytics, etc. And lastly, here's our team. Thank you.